So this is geotrig, lesson 10, day 2. Remember day 1 we did on the board. I don't have a video for that this year. You probably can find it from a past video if you put like geotrig lesson 10. So what we're going to talk about is, from before we talked about how you can find slope, how we can find slope intercept, we can find point slope. So today I want you to write the equation with this given information. I have 3 problems, 2 of them are here, and next one is going to be a graph. So you're going to have to pull the information yourself. And there's a couple different ways that we can do each one of these. So we also talked about parallel lines, because parallel lines have the what? Same slope. And perpendicular lines have opposite reciprocal slopes. So that's kind of the biggest things that we had to take from the last time we met. So if I give you 2 points and you had to write a line equation, you probably should find the slope. So we'll find the slope between the 2 points. Now, we talked about, I do believe last time, that when we find slope or the rate of change, it does not matter if I use x2 or y2 minus y1 over x2 minus x1 or y1 minus y2, but then I have to put it as x1 minus x2. So make sure that we do not, it does not matter the order as in which one's point 1 and which one's point 2. So I highly suggest that you go ahead and you place, I'm going to use a different color here, above it, x1, y1, x2, y2. So we have point 1 and point 2 there. And the nice thing about doing it this way with x1, y1, x2, y2 is that when we want to find slope, I can write down the slope formula. Because anytime you use a formula, you should be writing it down. What was that formula again? I just said it. Y minus 2 minus y1 over
x2 minus x1.
x2 minus x1. Here's a cool thing. The cool thing is you have a formula and you have the points labeled as x1, y1s, x2s, y2s. Just fill them in. What is y2?
4.
It's negative 3 minus y1? 2 over x2
4.
minus
Negative 3.
negative 3. What happens when you subtract a negative?
Positive.
Becomes positive, correct. So make sure you change that to a positive. This becomes a negative 5 over 7. So we know the slope between those 2 points is a negative 5/7. It could be 5 over negative 7 as well. But generally we like to take the negative either on top or bring it out front of the fraction. Everybody with me on that? We found slope many, many, many times before in our mathematical careers. Now, we want to write this in slope-intercept form. So if you guys remember, slope-intercept form was what again? Y equals mx plus b. A lot of us default and say, hey look, m is right there. So I can take m out and put a negative 7/5. It also has an x and a y in it. Well, guess what? Both of these pairs of numbers are x and y. You could substitute all of those pieces in and then solve for b, which is your, what is b called? The y-intercept. I'm going to flip it and say, wait a minute, that seems like a lot of work, a lot of substitution, then you have to rewrite. I personally will get to this point of y equals mx plus b, but I want to use this formula, which is point slope. So let's use point slope instead. I'm going to put m is the slope, so I'm going to put the negative 5/7 in. But x1, y1 can be the x1, y1 from my set of points. Actually, it could be the either set of points. Go for it. Try both of them. It's going to work. So y minus 2 That's y2, it's y1 equals negative 5/7 x minus a negative 3. You guys agree with that? And again, I'm minus a negative. Right here. Minusing a negative, you need to change it to add. Is everybody with me so far? Now, the only thing left is to solve for y, which means get this y by itself. I need to do what with negative 5/7? Multiply or distribute. So I'm going to have y minus 2 equals negative 5/7 x. That's an easy one. What happens when I take a negative 5/7 times 3? 3 can be written as a fraction. What is it? 3 over
1.
So negative 5 times 3? Negative 15. 1 times 7? 7. Now to get y by itself, I need to get rid of the 2, the minus 2. So I add 2. Hey, I have to put these two together here, don't I? Do they have a common denominator? 2 is over 1 again. What's the common denominator between a 1 and a 7? What is it? It's 7. So what's 2 times 7? So it'll be 14 over 7. What is a negative 15/7 plus 14/7? Is a minus 1/7. And now you've just made the line equation. Now, what's the difference between what this is and what you probably did in Algebra 1 or even Algebra 2? We have fractions. So they're kicked up just a little bit. Makes it a little bit more difficult because you've got to now worry about common denominators. Multiplying fractions. Remember, if you multiply fractions, you multiply across the top, multiply across the bottom. You do not need common denominators. Only adding and subtracting. Questions on that? Next question. You're going to pass through the point, negative 5, 5. And you have to be perpendicular to this line. To be perpendicular to this line means you will not use the same slope, but you will use opposite
slopes.
reciprocal slope. So, what's the slope of this line?
4x.
It is not 4x. Slope will never have a variable in it.
2. Or 4.
First of all,
2.
does anybody know or recall what form this is in right now? It's in standard form. Standard form is really nice because I can find my x and y intercepts very easily by basically solving for x and y when I put a 0 in for x or y, or the opposite one. This is not in slope-intercept form. None of these numbers, these coefficients, are the slope. I have to change it to a form like this to make that happen. So I got to solve for y. Subtract 4x. 3y equals negative 4x plus 2. To get y by itself, do what? Divide it by 3. So y equals negative 4/3 x plus 2. What's the slope of the original line? It's right in front of you guys. What's the slope of the original line? Negative 4/3. This is the old slope. Old slope equals negative 4/3. What's the new slope? What's the new slope going to be? Opposite? Reciprocal. What's it going to be? 3/4. So you're going to now use this slope in this point, using this process again, I'm going to give you guys 1.5 minutes to do this process and give me a line equation. Go. As you guys are working, I forgot to divide the 2 by 3. Okay, so it's 2/3, but here's the cool thing, it doesn't affect my slope because it's already taken care of there. So continue. Hopefully you guys have an answer by now. I just rewrote that slope and the point is there. I put the formula down that I'm going to use and now I'm going to start filling it in. Y minus 5 equals 3/4 x plus 5. Why is that a plus 5? I kind of skipped a step there. Why is it plus 5?
Minus equals
Yeah.
plus.
You're subtracting a negative, so it's going to add. Distribute equals 3/4 x plus 15/4. Add 5, add 5. It's really 5 over 1. But I'm going to multiply the bottom and top by. What am I going to multiply the bottom and top by to get a common denominator? 4, which is 20/4. I'm adding 20/4 to 15/4. So it's y equals 3/4 x plus. What's 15 plus 20? 35, whoops, fourths. Done. The last example of lines is they're going to give you some graphs here. They want you, there's 2 actual lines here if you can see them. We got the red line and we have this blue line. Okay? So the question is, let me make this larger. Can you take from this and can you create the equation of the lines?
Yes.
Let's start with the blue one. This blue line is a what kind of line? Horizontal. All horizontal lines start off how?
No slope. X equals 2.
Not x equal 2, but y equals 2, because all of the y values are what? 2. All the y values are 2. So this is y equals 2. But what about the red line? Can I say the same thing? Because that x equals or y equals? We're not actually going to find this. There's a couple different ways. Let me talk about them. One option. Doesn't this right here, what does this look like? 0 what? 0, 7. That's a point on this line. Would you agree? But 0, 7 is also the what? What is 0, 7? It's the y-intercept, aka your b value. Can you find another instance where you have a nice number? The other, oh yeah, right here. This is at 3, 0, right? -3, yep. It's -3, 0. So, question. You have 2 points. Can you find the slope using the slope formula?
Yeah.
And then you have a y-intercept. Could you make y equals mx plus b then?
Yeah.
Yes. Is this a positive slope or a negative slope? It's positive. It's on the way up. 2. If we have a graph, could I use the graph to find the slope? What is slope again?
Y is over run.
It's rise over run. How far up do I go to here? You're up 7? How far over do you go here? So, guess what? It's y equals 7/3 x plus 7. Done. So we can use the graph, if we're given one, to make some informed decisions about certain attributes of our graph. That is really cool. I didn't have to go through the whole slope formula and point slope form. So be careful and be mindful of the different pieces that you're given. Now, moving on to part B. Part B is rational denominators. We're going to talk about rationalizing those denominators. Remember, a rational number, guys, is a repeating decimal or anything that can be written as a fraction, a ratio or a fraction, and as terminating decimals. So that's a rational number. So 1/3. 2/7. 0.53 repeat. 0.53, 53, 53, 53, 53, 53, on. Those are all repeating ratios, fractions, those things. Irrational numbers are non-repeating decimals. They can't be written as a fraction. They're non-terminating. Like, example, square root of 2, 1.414, and then I don't know the rest. Square root of 3, square root of 5, square root of 7, pi. And complex numbers, we know, are numbers that involve what letter? I. You guys need to remember some of these things in the bottom here, that any square root times itself will just result in a number inside. Square root of 5 times square root of 5 is 5. Square root of 15 times the square root of 15 is 15. The square root of -1 we call I. And if you square I, you get -1. Those are things that we need to know because it's going to be very useful. Because what we're going to do is, as the title says, it's called rational denominators. Unfortunately, we're not given rational denominators. We'll have irrational denominators that we want to make rational. We don't like square roots or I in the basement, in the denominators. So, guys, this is the process of converting the denominator to a rational number, and it's called rationalizing the denominator. I've got 6 steps. I would write these down. This is why I asked you guys to print them. Save your hand from cramping up here. To rationalize the denominator, you must multiply the numerator and the denominator by the conjugate of the denominator. Now, we don't always have to use the conjugate. But the conjugate is where you change the sign between the two terms. So, example, 2 minus the square root of 3. If this was the denominator of your problem, 2 plus the square root of 3 will be the conjugate. Those are conjugates of each other. So when one's there, we're going to multiply by the other one. Because guess what? This sets up the sum and difference, which allows us to have the difference of squares. And if that's the case, no more square roots. No more i's. So if I had 2 minus 3i, the conjugate is 2 plus 3i. Those are conjugates. If one's there, you put the other one in. You multiply it. But what you do to the bottom, you have to do to the top. It is okay to have i's and square roots in the numerator, the top, but it's not okay in the basement or the denominator. Now, we got to be careful because not every denominator looks like this with multiple pieces. You could have 2i in the basement only. We don't have to go as far as where we're calling it the conjugate. Then we just multiply by the piece that's the problem. The problem is I. To get rid of I, I'm going to multiply it by another I, because then it becomes I
Squared.
and I squared is -1. It's gone. But don't forget what you do to the bottom, you have to do to the top. The next slide is going to have those examples there that'll helpfully bring this home. So we multiply top and bottom, numerator, denominator, by the conjugate, if needed. You're going to distribute, FOIL those numerators and denominators. Make sure that numbers that are outside radicals stay outside radicals. Numbers like a square root times a square root, you can multiply those inside, those type of problems. 3, combine your like terms. Simplify your radicals. Please don't leave it as the square root of 50. Take it to the dance. 5 times the square root of 2. Combine any like terms you can. Reduce the fraction if you can. So it's just good practice, right? Always write it in simplified form. When it's a fraction, that means reduce it, reduce it, reduce it. Anytime you can multiply, you multiply it out. Those types of things. Okay? So here we go. First one kind of demonstrates what I was talking about in the very beginning, or at the end, sorry, how it's not the conjugate. I don't care about, it doesn't have any pluses or minuses on the bottom. So the culprit here is square root of 2. How do you get rid of a square root of 2?
Multiply by square root of 2.
Multiply by square root of 2. But what I do to the bottom, I have to do to the top. So what's 5 times square root of 2? It's not square root of 10. It is 5 square root of 2. What is square root of 2 times square root of 2? 2. Guess what? You can't reduce it anymore. That's your answer. That is called rationalizing the denominator. Okay? Not too bad, is it? So then I can kick it up a notch with number 2. What's the culprit?
Square root of 3.
The square root of 3, but only the square root of 3 where? In the bottom, or in the basement, or in the denominator. So, I'm going to multiply that denominator by what? What do I want to multiply the denominator by? Square root of 3, but what I do to the bottom, I have to do to the top. Wait a minute. The bottom is a single number. That's great. That's awesome. The top has how many numbers, though? What does the numerator have?
Square root of 3.
It has a 2 minus square root of 3. That's a binomial. That means you need to distribute on top. Square root of 3 times square root of 3 gives you a 3 in the denominator. Awesome. But what's 2 times square root of 3, right? 2 times square root of 3. What is 2 times square root of 3? Can we put it together?
2 square root of 3.
It's 2 square root of 3. And then minus, right? Because it's a negative square root of 3 times 3, square root of 3. So it's minus 3. Guess what? Done. No more culprits in the bottom. I'm okay with that. In the initial part, I said I don't like i's in the basement either. Because what is I? It's not -1. That's I squared.
Wait.
What is I?
Wait. I have a question on the last one.
Okay, let's go back.
I don't get it.
I distributed the square root of 3 to 2, and that's why you have 2 square root of 3.
Yeah.
And square root of 3 times negative square root of 3 is a negative 3. The square root of 3 times square root of 3 is 3. What's that?
You kept square root of 3.
On the 2, yes, because it doesn't cancel. Doesn't simplify. Doesn't go away.
Alright, I got it. Thank you.
Why don't I like I in the basement?
Negative.
What does I represent? You guys all know this. Square root of -1. I is a square root. So, to get rid of I in the basement, multiply it by what? I. So what I do to the bottom, I have to do to the top. What's 6 times I? 6I. What's I times I?
-1.
You can do I squared, which then makes it 6I over -1, which then becomes -6I. Done. So it's not too bad if you take it step by step. Okay, now we're going to kick it up. Now you have a binomial divided by a binomial. The bottom is a culprit there with that square root of 2, right? But think of this. Don't write this down yet. All the rest of the problems, if I just multiply by what the problem was, in this case, square root of 2. If I try multiplying that to the bottom, square root of 2 times square root of 2 gets rid of the square root, right?
Yes.
But here's the problem. I have to distribute all the way to the 3. And what would happen then? It'd be 3 times square root of 2, which leaves us with a square root in the bottom. Not good enough. So I can't do that. So instead, I need to multiply the top and the bottom by the conjugate. What's the conjugate of the bottom?
Square root of 2.
Remember, it's the same bottom, but switch the sign. So it's 3
Minus square root of 2.
minus square root of 2. What you do to the bottom, you do to the top. Then you have to 4-letter F word the top and the bottom. Foil the top, foil the bottom. This is where the work comes in. This is actually now going to take a little bit. It's because now I have to do 5 times 3. 15. 5 times negative square root of 2 is a minus 5 square root of 2. Negative square root of 2 times 3 is a negative 3 square root of 2. And a negative negative makes a
Positive.
And a square root of 2 times square root of 2 is square root of 4, which is 2. I'd rather simplify it in my head. It's one less step that I'll have to do. All of that is on top. Now you got to do the same thing on the bottom. What is 3 times 3?
9.
9. 3 times a negative square root of 2.
3 square root of -3 square root of 2.
Whoops, why did I put 2 square roots there?
That's silly.
Negative 3 square root of 2. And then I go to the middle. Look. Square root of 2 times a positive 3 is a positive 3 square root of 2. Ooh, what's going to happen there?
Cancel out.
They will. And a positive square root of 2 times a negative square root of 2 is a minus 2. You guys see that?
Yeah, I see it already.
We've done that a couple times, I think, in this class already. The top, 15 plus 2. What's 15 plus 2? 17. Negative 5 of the square root of 2's and minus 3 of them is a minus 8 square root 2. All over. The middles cancel. I hope you guys see that you got a negative 3 of them and a positive 3 of them. They cancel. They simplify to 0. And what's 9 minus 2? 7. Done. Some books, some problems may ask you to separate those. So you could say it's 17 over 7 minus 8 square root of 2 over 7, right? Not that big of a deal. The same thing happens with 5. But before we get to 5, are there any questions? Same thing. I got to get rid of 2 plus I on the bottom, so I multiply by what? 2 minus I. 2 minus I, 2 minus I. Guys, guess what? If I cover this up, what's 2 minus I divided by 2 minus I? What is something divided by itself?
1.
1. So I'm multiplying this fraction right here by 1. Does it change it? No. That's why rationalizing the denominator works. You multiply so that you don't change it. Because what I do to the bottom, I do to the top. What's 1 times 2 minus I? It's just 2 minus I. That's awesome. The bottom you have to FOIL. 2 times 2. 2 times negative I. Minus 2I. I times 2. Positive 2I. And what's a I times a negative I? It's a negative I squared, yeah? So this becomes 2 minus I over. The 2 i's do what? Cancel. 4 minus negative 1, because I squared is negative 1, which actually results in what? 2 negatives make a 5. Now, because this is imaginary numbers, you probably should split it to write it in a plus bi form, right? So what's the real part? 2/5 minus 1/5 I. Your homework on lesson 10, day 2 is page 80, 5 through 9 in 11. Have a great day.